Hello everyone, today is February 27th, 2019. This is 16th episode about C++ type function, modern C++ programming. In this episode, we will understand what is immediate context. Immediate context plays very important role to modern C++ and future C++ programming. I have been thinking about this video pretty long time. And I finally decided to film about immediate context. I plucked up all my courage to film this video. This is working draft standard for C++ programming language. This is 2017 March 21st. This is not ISO C++ standard documentation, but it is working draft. So it is very close to C++ standard. It is 1622 pages long. And I searched for immediate context and we can find it the first occurrence of immediate context in C++ standard working draft. From here, therefore, any use of specialization of function template will cause implicit instantiation. So what it means is if we use function template specialization, then implicit instantiation occurs. Any error that arises from this instantiation means implicit instantiation. If any error arises from this instantiation are not in immediate context of the function type and can result in program being ill-formed. Then I search again for a while later, and page 421, access checking is done as part of substitution process. Only invalid type and expression in the immediate context of the function type and in its template parameter type can result in deduction failure. The substitution into type and expression can result in effects such as instantiation of template specialization or function template specialization. Substitution into type and expression result in instantiation of a class template specialization and or function template specialization. Then the generation of implicitly defined function, etc. Such effects are not in immediate context and result in program being ill-formed. And if we search again, and here the same texts are repeated. The same texts are all repeated. Here in page 702, the same text is repeated and the same text is repeated. So to the end of working draft standard for programming C++ language, I cannot find any useful definition for immediate context. But immediate context plays very important role in understanding template metaprogramming or type functions. I filmed 3 videos about SFINAE and type function before, also how to test if a type is iterator, and the generic template metaprogramming about concepts in C++ 20. Please watch these 3 videos very carefully because these are very important videos about modern C++ programming. When I planned for C++ type function and modern C++ programming, this series of videos, I had a plan to help my audience learn modern C++ as well as to prepare my audience for future C++ language. If you want to understand type functions and SFINAE, substitution failure is not an error correctly, we have to understand what is immediate context. C++ 20 standard will introduce concept. I explained what is concept in this video. So if we want to understand what is concept, if we can take advantage of concept in C++ 20 standard, we need to have a concrete understanding what is immediate context and how to use type function properly. I plucked up all my courage to film this video. we need to have our type libraries, so please visit this link, and from our previous video please download the source code. Show in folder, double click it, copy the folder, copy, paste it to your working folder. Double click the folder path, copy, right click your command prompt, paste, click OK, start Visual Studio Code. File, open folder, paste it your folder path, enter, select folder, Control minus, then click in the blank space here, click this button, 16, immediate context, enter, PCH CPP, immediate CPP. In the PCH file, include talk, play, fun, type library, util, include type tutorial function, type lib. In PCH file, include PCH immediate, include PCH. Right click, save all, make sure save all, then close all others. Close others here, auto, stream, talk, play, fun, stream, auto, NL, stream, get console, out, int main, stream, welcome to immediate context. In command prompt, dir cd 16 immediate context, dir cl at pch local pch cpp. We are compiling precompiled header, cl msbc local immediate cpp. Okay, you should see this message successfully. Also try G++, std, C++17, PCH, then G++, std, C++17, immediate cpp, or mexe. Please note that I changed the file name to mexe. Okay, it should work like this. Suppose we are overloading these two functions, int, even or odd, return 1. We are overloading this function in this way, double, even or odd, return 3.14 So we overloaded two functions. Does it work? No, it doesn't. It doesn't work. Because function call parameter, they are identical, function name is identical, return type is different. We cannot overload these two functions normally. But there is a way to overload these two functions. You might ask, overloading these two functions are any useful? Yes. Overloading this kind of function proves very useful. I will show you shortly. So please follow with me. Immediate context is used for overloading functions. More specifically, it is used to overload function templates that return template types. Immediate context is also used for the functions with auto placeholder with trailing return type. About this, I will talk very shortly. So, immediate context is used for overloading functions. It is used to overload function templates that return template types. Immediate context is in function templates template return type. Immediate context is in the trailing return type specification of the function with auto return type placeholder. I will change it like this, also like this, like this. Now let's turn these two functions into template functions like this. Before we turn these into template function, I will define some type functions like this. Template bool be even false. Struct is even st. This false means it's the same like this, false. Okay, the case of false. When n is even, we do not define type member here. We make specialization like this. Template struct is even st. It is specialization true. When n is even, this is when n is not even. When n is even, we define type member as below using type int. Now we define another one. Template bool be add false. Struct is add st. This is the same like this, false. N is not add. We do not define when n is add. We do not define type member. This is specialization. Template struct is add st true. N is add. In this case, when n is add, we define type member as below using type double. Okay, so we defined is odd st, is even st. Now we make some type functions here like this: template bool be even using even t. We copy this function be even type. We have to prepend the type here, type name like this. We defined this type function, and also here are the template bool be add using is add t. We copy this function be add type. We need a type name here, type name. I will change it to is even t like this. With this introduction, we can now overload these two functions like this: template size t, or we can just say n, int, n is even key n modulo 2 equal 0. Okay, look this part. Then we remove int. This is template return type. Now here template intn is add t n modulo 2 equal 1. Okay, template return type. Now with these two introduction, then let's compile. Okay, it compiles. Now let's test. Void test even or odd, or and even or odd 4. We are calling this function. These two functions are overloaded, or and odd, even or odd 5. Okay, now I will modify it here, return type n 2 times n. In this case it is even case, and this is odd case. Then we can modify like this: n times n square, n squared. Okay, now we display the result and the type like this: stream n even type of n even, talk play fun, get type category n even. We copy once again, and add. and other type of and other and other. Now we build and run again. Okay, so we have to call this function. Okay, so n is even. We passed for 2 times n. It returns type int. In this case, when we passed odd, in this case 5 squared 25, the type is double. We effectively overloaded 2 functions with different return type with the same parameter count. How this works? When we call even or odd for this function, C++ compiler builds function overloading candidates list. Initially, C++ compiler finds the functions named even odd that matches function call parameter list. In this case, C++ compiler builds this function and this function. Then C++ compiler substitutes for this number for n. Then template for is even t. Here, if 4 is replaced, this value becomes 0. 0 equals 0. Even or odd. Also template for, we substitute the number 4 in this function like this, is add t 0 equal 1, even or odd. This is substitution stage. Then, since in this case even t, this is true, this becomes true, and this is false, and it compares this, then it compares with this is even t. Since b is even, in this case true, in this case is even t true, then is even t, this is true, then it becomes true, then this type is int, then it returns int, because if even is true, then is even st is true, this is even st true is selected, then each type is int, then it becomes, this becomes int. So it is replaced here at this stage. Then it becomes like this. Without template, this is int, like this. Now in this case, add is add t false, then this function is called is add t. It is false, it is false, then the type does not exist. Type does not exist. This type member does not exist. If brd is false, is add st false, this is false, this type does not exist, so it is empty. Okay, it is empty. Then it becomes, it is empty. This part is empty, so it becomes like this. Okay, this is valid function. This is invalid. So when the function is invalid, the return type here, return type is immediate context. Immediate context. Okay, so if substitution failed, the failed function is removed from the function overloading candidates. So only this function is left in the function overloading candidates list. So this function is called, this function. So this function is called because it failed. In this case, in other case, it is failed. In the same manner, when the C++ compiler sees this function call, C++ compiler builds function overloading candidates list as below. It will build these two functions. Then substitute 5, this number 5, for template parameters, like this. Now I will drop this n template part, then it becomes like this. This is 5. This is 5. Then it becomes, then this candidate list becomes like this. This is 0, 1. This is 1. Okay, so then it becomes again like this. This is false. This is true. Now is even t false? Is even t false? If it is false, is even st false becomes this one. This type is empty. This type is empty. It does not exist. So it becomes empty, like this. So here it becomes empty like this. And this part is add true, is add true, is add true. If it is true, then it has type double. Is add t true becomes type double through this. This type is double. It becomes copied true like this. Now it is valid. This is no, not true. This is double. Now it is invalid. This is valid. So this other function gets called. Then this candidate gets removed from the candidates list. Invalid function overloading candidates is removed, and valid function overloading candidates is selected for function call. This function return type is immediate context. This place of the function template return type is immediate context. When substitution fails, the corresponding function candidate is removed from the overloading candidate list. This is the principle. Immediate context is the place where SFINAE or substitution failure is not an error works. Now I copy this text and paste it here. Thomas Kim's definition for immediate context. Immediate context is the spot or the place in C++ .h or .cpp file where SFINAE or substitution failure is not an error works. In this broader sense of the immediate context, immediate context is used for overloading functions. B. Immediate context is also used for class template specializations. About immediate context used for class template specialization, I will deal about this in future sessions, not in this session. We've just learned in this case A-1. More specifically, it is used to overload function templates that return template type. We just learned this example. Now let's turn a second usage. Immediate context is also used for functions with auto placeholder with trailing return type. Now let's talk about this concept. Suppose we are creating a function like this, template, type name T, I will say auto, sum, T A, T B. Return A plus B. Now let's think about this function, void test trailing return type specification. Okay, now we test this function like this: auto r1 sum 4 5 stream r1 equals r1, and there. Now we call this function. I will copy, I disable it, and we compile and run. Okay, it works properly, but let's try this one. Auto r2 r1 sum 5.0. If we build it, it does not work. It does not work because in case of 4, a becomes t is integral type. In this case 5.0, in this case t becomes double, so it conflicts. So we disable this and we introduce new template parameter like this, s type name t like this, and s t. Then let's try this function. This is fixed one, and now it works. But there is another problem with this approach. Let's try with this one. What's up? Say I modified like this. Sorry, I will restore it, and I copy it once again here. What's up? Like this. Now let's build. Will it work? Will it work? Let's try it. Yes, it works. But the result of all is a little bit strange. Okay? How come it work? How come this sum function work? We originally wanted to solve the problem of this approach. Then we introduced another template parameter s. We solved this problem, but we have another problem, unexpected problem. How can we solve this problem? Let's understand how it works first. In this case, function sum, 4 is integer here, 4 becomes a, and s is type integer. So to simulate this, int a equals 4, and in this case, what's up? The type of t becomes constant character pointer or array. So we can define like this: constant character pointer b equals what's up. We defined like this. This sum returns the sum of a and b. So here again, auto r2 a plus b. Okay, now let's display here stream r2 and l. Okay, now let's run it. So r1 r2 is the same. So this is int plus constant character pointer arithmetic. So in C++, in C and C++, pointers can be added to or subtracted from int. If we want to prevent pointers and int arithmetic, we need to create a type functions. For this purpose, we will be using ternary operator. By default, the ternary operator returns the common type of the two arguments as below. I think I have to fix this part. In C++, int can be added to or subtracted from pointers. I modified like this. Also, there is a typo. By default, ternary operator returns the common type of the two arguments as below. Okay, now I will define double D 5.0 auto R3 true A D. This ternary operator returns the common type of the two arguments A and D. We are not interested in the return value of this ternary operator. We are interested in the type of this return value. So we want to find out the type of R3 like this using R3T DECL type R3. R3T has the type of the ternary expression true A D. So we print out the type of R3 like this, stream the type of R3 T. Then talk play fun, get type name R3 T and L. So I will move this part, cut, and I will paste it here, and I will disable this. Now let's build this function M. So when integer and double are operated, int and double are operated, the resultant type is double. Okay, when this A is integer type, D is double type, when they are operated, the resultant type is double. This is the mechanism C++ standard library type function std command. Okay, but this std command is, from my perspective, a misnomer. It should have been named as std is operable. We should not use std command to get the common type of two arguments. I will address this issue in my future sessions. We should never use std command to extract the common type of two type parameters, type arguments. I will explain the reason why we should never use std command to extract the common type of two type arguments in some future sessions. It is really important. Now let's think how we can use this ternary operator like this. Now here we define the character A, B as one is int, B is character pointer. We can try like this: auto test true A, B. What is the common type? Int and a pointer. Now let's try this code. It fails. 176. This line fails. We cannot get the common type of an int and a pointer. This feature turns out to be really useful. So I disable it and we fix like this. Now I copy and disable. I paste. We are using trailing context like this. DECL type A plus B. It means this is auto here. This auto is called return type placeholder auto. And this DECL type expression is called trailing return type specification. We fixed like this and I disabled this, and let's build. I will disable this part too. And I re-enable this part so it works as before. Now it works. If we prevent from here, if we prevent this operation R1 still works. R1, this R1 still works. Integer constant pointer operation still works. If we want to disable this smartly, we can modify like this. I will disable this once again and paste here. Watch it carefully. The DECL type like this: true A, B. This returns the common type of two arguments A and B only when A and B are operable. With this, let's turn. This function does not work. This fails. Now let's try it. Fails. Now another one. We enable this. Now it works. It works as before. It works perfectly. But we effectively disable this operation. Now with this function, we effectively disabled this operation. Integer with the point operation gets failed here. Failed. Okay, so this is really useful operation. We can make it into a type function. So when we want to test if the operation between two arguments are possible, we can use true A, B expression. If A and B are operable, true A, B returns the common type of A and B. If not operable, this function effectively SFINAE out. I will talk more about this. So this is called trailing context, return type trailing context. This expression plays really important role in advanced template metaprogramming. Also please note that I said std common. std common is built using this ternary operator, and it causes lots of problems if you don't understand it correctly. In my future sessions, I will explain in detail why you should not use std common to extract common type of two arguments. std common is more like misnomer. It should be fixed is operable. Here, we use this ternary operator if these two arguments A and B are operable or not. In summary, we learned immediate context in this session, and we learned immediate context is used to overload the function templates that return template type. Then we also learned immediate context can also be used for the functions with auto placeholder with trailing return type. In some future sessions, I will also talk about immediate context also used for class template specification. Concrete understanding, say, if we understand function object or functional object in C++, C++ lambda is very simple and easy to understand. In the same manner, if we understand immediate context and SFINAE, we can readily understand C++ concepts that will be introduced to C++ 20 standard. Please subscribe to my YouTube channel. Thank you for watching.